welcome back. So in this video, we will be talking about how to handle missing values. Okay, so yeah, yeah, I'll just close that. Okay, so the first method we have simply just deleting, right, missing rows. So missing values can be handled by deleting the rows or columns having null values. So if the columns have more than half of the rows as null, then the entire column can be dropped simply. The rows are uh, those rows which are having one or more columns values as null can also be dropped. The pros of using this method is that this creates a robust model, right? But the thing is, we actually lose a lot of information and it works poorly. The percentage of missing values is actually very large in comparison with the complete data set, right? And then the next method, we actually have the imputing missing values, right, for continuous variable, or shall we say imputing missing values with mean or median. So columns in a dataset which are having numeric continuous values can be replaced with mean or median of the remaining values in the column. Yeah, this method can actually prevent the loss of data um, as compared to like the previous method, and it is actually the statistical approach, right, to handle the missing values. Um, okay, so it does prevent data loss, right, by simply like if as compared to like actually just doing stuff, and it works well with the small data set. It's very easy to implement, right? We can implement it manually, even. It's very easy. The cons of using this is that it only works with numerical continuous variables, and it can actually cause data leakage. Yeah. Another thing is that it does not actually factor the covariance between features. Okay. So yeah. Okay, moving on. So we have the imputation method for categorical variables. Okay, so when the missing value is a categorical column, a categorical feature, perhaps it's a string, right? Or something like, for example, in our case would be the output, right, is whether it's malignant or benign, then the missing values can be replaced with the most frequent category or the mode of that particular column. So, but of course, we don't actually just simply change the output, right? That's not the, the purpose of our you know project, right? If the one of the features to be considered is actually a categorical column, right, and it has missing values, we can just replace it with like um, the whichever is you know whichever has the highest frequency, right, in that particular column, essentially. So the pros of using this is actually prevention of lost data is the same, right? As compared to like simply deleting rows or columns. It works well with small data set. It's easy to implement. Um, it negates the loss of data by adding a unique category. Okay. So, but the cons is that it only works with categorical variables, and yeah, addition of new features to the model while encoding may result in poor performance. So, so far we have three, right? I think these three are the most common ones to actually be used. Um, but the thing is, yeah, and mind you that we have so many scenarios, right? Like for example, we have a data set in which the null values, the missing values, are actually very little as compared to like the whole data set. Like for example, perhaps like 5%, maybe 10%, but like if it reaches like a significant number, such as like 30% or even 50, right, we should probably consider actually other methods, right? Like perhaps even considering like oversampling or undersampling, which have like a lot of other methods as well, and all the imputations and stuff, all the like perhaps simply deleting is not suitable for those cases, right, in which the missing values is actually pretty big. in comparison with the whole data set. Okay, so and we actually have other imputation methods. We can use algorithms that support missing values, right? So yeah, for example, like a lot of machine learning algorithms don't actually support missing values, but some ML algorithms are, robust to missing values in the data set. Like for example, the KNN. Like, to be fair, it's kind of like a lazy learner algorithm. It can actually ignore a column from a distance measure when a value is missing. Like for example, a naive Bayes, it can also support missing values. These algorithms can be used when the data set contains, a lot of null or missing values, right? Um, the sklearn implementations of naive Bayes and KNN, however, in Python, like, do not support the presence of missing values. So we should actually do a lot of preprocessing, right? Still. You know. Another algorithm that can be used is actually random forest. It works well with nonlinear and categorical data. It adapts to the data structure, taking into consideration like high variance or the bias, producing better results on large data sets. And the pros is that there's no need to handle missing values, right? The cons is that, yeah, if we simply just use scikit-learn, there's no implementation of, algorithms that can actually handle missing values itself. So then we can also predict, right, the missing values. Um, so the regression or classification model can be used to predict missing values, depending on the nature, like if it's categorical or numerical slash continuous, right? Um, or the feature having like missing values. So yeah, the pros is that it gives better results than earlier methods. It takes into account the covariance between one missing column to another. So that's good, right? They're actually it's actually taking into account the covariance as well. But the cons is that it is considered only as a proxy to the true values. Okay. And last but not least, we have the deep learning library. So this works well with a lot of like various nature of like the feature. It has the categorical, the continuous, the non-numerical feature stuff, and one of the library that supports this is called the Data Wig. It is a library that learns ML models using deep neural networks to impute missing values, right? So yeah, the pros of using this, yeah, quite accurate compared to other methods, and it supports both CPU and GPUs. So like it can run on either CPUs or GPUs depending on like the hardware you have, whichever one is um, more powerful in your setup, right? Like perhaps your CPU or your GPU causes a bottleneck, right, into the whole system, and you would prefer to use one or the other, right, more intensively, right? So yeah. And the cons is that it can be quite slow because it's actually computationally expensive, right? So with large data set, it can actually take some time and computationally expensive. I suppose that's it for handling missing values, and I'll see you in the next video.